Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring function transformations. Now, many of these transformations you'll have seen in previous courses, and some of this may be new. So, in this lesson, we're going to review functions that go from f of x to a times f of b times the quantity x plus c plus d. Now, let's start off by talking about what these different variables affect. So a and d, notice how they're on the outside of the function. They're going to affect the output or y values of the function. All right. Then we have the b and the c. These two variables are grouped up with the x. And so these are going to control the input or the x values of the function. All right. Now, in example 1, we have this crazy little function drawn here. It says the function y equals f of x is shown below. Create a table of values to represent f of x. Actually, I did that for you because it took a little bit of time to do that. For each transformation rule, make a table of values, graph, and then describe the transformation. So in problem A, our transformation rule is g of x is equal to f of x plus 3. So this plus 3 is on the outside of the function, which means it's going to affect my y values. And in fact, what we're going to do is add 3 to each y value. So you're going to look at your original y values here. You're going to take that first y value, which is 0, and you're going to add 3 to it. So 0 plus 3 is 3. Then you're going to take your next y value, which is negative 3, and add 3 to that, which would give you 0. Then you take your next y value, which is 1, and add 3 to that, and get 4, and do that with the last 3 numbers. So 0 plus 3 is 3, 1 plus 3 is 4, 0 plus 3 is 3. Now, what we're going to do now is we're going to plot these. Let me erase all these here. Okay, so what I want to do now is plot the transformation f of x plus 3, and then we'll compare it to our original function. So I'll put a point at negative 3, positive 3, negative 1, 0, 0, 4, 1, 3, 2, 4, and 3, 3. Now I'm going to connect those dots straight as I can here. And then we're going to compare it. So when I compare it to the original function, it looks like this new function, every single point shifted up 3 units. So it wanted us to describe the transformation. So I'm going to say the function shifted up 3 units. All right. Problem B, g of x equals f of x minus 3. Now, hopefully you learned in previous courses that when you're doing transformations, when you have a number that's grouped in the parentheses with x, you're going to do the opposite. So we're going to add 3 to each x value. Remember, when we have numbers grouped with x, it changes the input or the x values. All right, so I'm going to take this first x value, negative 3, and add 3 to it, and that will give me 0. Then take your next x value, negative 1, and add 3. That will give you 2. Now take your next x value, 0, and add 3 to it. Then take your next x value, which is 1, and add 3 to it. That would give you 4. 2 plus 3 is 5. 3 plus 3 is 6. So once you've added 3 to each x value, now we're going to plot the transformation f of x minus 3. So our first point is 0, 0, 2, negative 3, 3, 1, 4, 0, 5, 1, and 6, 0. So let me connect these. Now we're going to compare this function to the original function at the top of our page, and this function shifted to the right 3 units. It shifted everything to the right 3 units. Now, next function, we have 2 different operations going on. We have something with the x, so whatever's in here is going to affect your x values, and because it's grouped up with the x, we're going to do the opposite. So I'm going to say subtract 2 from x. Then we have a number on the outside. The numbers on the outside of the function affect y, so I will subtract 1 from each y. All right, so let's go back up to my original table. Let's do the x's first. I want to take my first x, negative 3, and subtract 2. So that would give me negative 5. Then take negative 1 and subtract 2. That would give me negative 3. Now take 0 and subtract 2. Take 1 and subtract 2. Take 2 and subtract 2. And 3 and subtract 2. That'd be 1. Now for the y's, you're going to subtract 1 from the y values. So our first y value was 0. 0 minus 1 is negative 1. Negative 3 minus 1, negative 4. 1 minus 1 is 0. 0 minus 1 is negative 1. 1 minus 1 is 0. 0 minus 1 is negative 1. All right, let's plot that and compare it to our original. So negative 5, negative 1. 1, 2, 3, 4, 5, negative 1. 1, 2, 3, 1, 2, 3, 4. Negative 2, 0. Negative 1, negative 1. 0, 0, and 1, negative 1. All right, so this shape shifted left 2 and down 1. So that's, it says to describe left 2, down 1. All right. Problem D, we have g of x equals negative of f of x. So this negative is on the outside of the function, so it's only going to affect our y values. So you're going to multiply y by negative 1. So I'm going to take my y values. My first y value is 0 times negative 1 is still 0. Negative 3 times negative 1 would be positive 3. 1 times negative 1 is negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. And 0 times negative 1 is 0. All right, let's plot these points. 1, 2, 3, negative 3, 0. Negative 1, 1, 2, 3. 0, negative 1. 1, 0. 2, negative 1. And 3, 0. All right, now let's plot these. So this transformation reflected or flipped our function over. So I'm going to say that this was a reflection across the x-axis. All right, problem E. G of x equals 2 times f of x. Well, just like the last problem we did, this number's on the outside of the function, so it's only going to affect our y values. So we'll say multiply y, each y, by 2. Now what I'd like you to do on your own is pause the video, fill in the table, and then plot your points. When you're ready to check your answer, press play. All right, welcome back. Let's see how you did. All right, 0 times 2 was still 0. -3 times 2 was -6. 1 times 2 was 2. 0 times 2 is 0. 1 times 2 is 2, and this was 0. So check your table first. Now let's plot those points. -3, 0. -1, 1, 2, 3, 4, 6. 0, 2. 1, 0. 2, 2. And 3, 0. All right, now let's compare this to our original shape up here at the top. And I hope you can see that this function has been vertically stretched by a factor of 2. So I'll just abbreviate that, BFO, by a factor of 2. In other words, all the y values doubled, which stretched your shape out. Okay. Now, F is really weird. You may or may not have seen this transformation in previous grades, so this one may be new for you. But in our parenthesis here, we have a b value of 1/2. So if your number is grouped with x, your x, it's going to affect your x values. And what we're going to do here is we're going to multiply all of the x's by the reciprocal. So let's see, I'm going to multiply the x's by the reciprocal of 1/2 is 2. So whenever you're grouped up with x, like up here, we did the opposite, we subtracted 3. Here, we're going to multiply everything by 2 instead of 1/2. So I'm going back to my original x's. -3 times 2 is -6. -1 times 2, -2. 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4, and 3 times 2 is 6. All right, now let's plot this. -6, 0, 1, 2, 3, 4, 5, 6, 0. -2, -3. 0, 1. 2, 0. 4, 1. 1, 2, 3, 4, 1. And 6, 0. So our new function looks like this. And I want to zoom out here so I can compare it to the original function. Now, I want you to notice that this has been horizontally stretched. In other words, it spread them out along the y-axis. It horizontally stretched them by a factor of 2, BFO2, by a factor of 2. All right. That one's a little weird, and it'll just take time to get used to it. But we'll be studying these transformations on different types of functions all throughout the year. So by the end of the year, it'll make a lot more sense for you. Okay. Now, in this table, we're going to summarize all of the translations that we just did. So if we have f of x plus d, plus a number, that simply means you're going to move up d units. If we have f of x minus d, we'll move down. Move the function down d units. When you have a horizontal translation, if you have x plus c, remember the c is grouped with x, so you do the opposite. So this would be left c units. If you have x minus c, it's going to move, your function will move to the right c units. If you have a negative in front, that reflects across the x-axis. If you have a negative grouped with the x, it reflects over the y axis. Now, when you have a number in front or attached to f of x by multiplication, it will vertically stretch when a is greater than 1, or it will vertically compress when a is between 0, 1, 1. Now, f of bx, when b is greater than 1, it will horizontally compress. And if b is between 0 and 1, it will horizontally stretch. Now, in example 2, we're not going to graph these transformations. We're just going to describe what will happen. So we have g of x is equal to 3 times f of x plus 2. So our a here is 3, and our d is equal to 2. So we're going to vertically stretch by a factor of 2, and then the other 2 will move up the graph 2 units. All right. In problem B, we have 1/3 times f of x minus 1 plus 2. So in this problem, our a value is 1/3, our c value is positive 1, and our d value is 2. So when the a value is between 0 and 1, it will vertically compress by a factor of 1/3. The minus 1 will make it move to the right 1, and the plus 2 will move it up 2. All right, in problem C, we have g of x is equal to negative f of x plus 4. So when we have a negative in front of our function, that will reflect across the x-axis, and the plus 4 will make it go left 4. All right. G of x equals 5/2 times f of x minus 1. Now 5/2 is the same thing as 2.5. So our a value is 2.5. Our d value is negative 1. So this will vertically stretch by a factor of 5/2, or 2.5, and it will move down 1 unit. All right, f of negative 3x. All right, when we have a negative inside the parenthesis, it reflects across the y-axis. And then we take the reciprocal of 3, which is 1/3. And so that will be a vertically compressed, oh, I'm sorry, I didn't mean vertically. This is grouped with the x, so it's going to horizontally stretch, sorry, I meant compression, horizontal compression, let me abbreviate that, by a factor of whatever the reciprocal of 3 is, 1/3. All right, example 3. If the quadratic function f of x has a vertex at negative 3, 7, then where does the quadratic function g, defined by g of x equals f of x minus 4 plus 2, have a vertex? So we're transforming it here. We're going to, we have x minus 4, so that's grouped with the x's, so we do the opposite. So we'll add 4 to x, and then the plus 2 means add 2 to the y. So if our original vertex was negative 3, 7, we're going to have to add 4 to the x value, and we'll have to add 2 to the y value. So my new vertex would be negative 3 plus 4 is 1, 7 plus 2 is 9. And that concludes today's lesson, Introduction to Function Transformations.